In this next video, we're going to discuss how the definite integral relates back to area. If y equals f of x is a non-negative and integrable over a closed interval a to b, then the area under the curve y equals f of x from a to b is the integral of f from a to b. So what I mean by this is that if we had an integral from a to b of f of x dx, this is actually equal to the area underneath the curve. So this is equal to the area under the curve. And this makes sense because the integral is the sum of all the rectangles as the width becomes infinitely small. So something you want to note is that the definition works both ways. Integrals can be used to calculate areas, and you can find the area to calculate integrals. This leads me to example 2. We're going to revisit the train problem that we did in example, I think it was 1 or 2 in section 5.1. So a train travels at a constant speed of 75 miles an hour from 7 a.m. to 9 a.m. We want to express the total area as an integral. Now remember back from that problem that the equation was f of x equals 75 miles per hour. So we want to express the total area as an integral. So the starting point of the integral was 7 a.m. and the ending point was 9 a.m. And remember that an integral is from a to b f of x dx. So my f of x is going to be 75 miles per hour. So it's 75. And then because we're expressing it in time, we're going to write dt instead of dx. As long as you have the correct letter, it doesn't really matter what letter you choose here. If you're letting x represent time, you could have used dx. But since it's time and it's letter t, we're going to use dt. So when we integrate that, remember this is the area under the curve, and the area under the curve was 75, because that was the height, times the width, which was 9 minus 7. So you get 75 times 2, which is 150 miles. So in 2 hours, he drove 150 miles. Now what I want you to do is try this one on your own. A train travels at a speed of 60 miles an hour from 11 a.m. to 2 p.m. Express your answer as an integral and find the distance traveled. So go ahead, pause the video, and try this one on your own. Okay, let's do it together and make sure you got it right. So we have the integral from a to b, which was 11 a.m. Now we go to 2 p.m. Now you can't actually write a 2 because you want to have it increase by 3 hours. So 3 hours past 11 is 14. The reason we don't do 2 is because if you did 2 minus 11, you don't get 3. 14 minus 11 is 3. And then our function then is going to be 60, because we're going at 60 miles an hour, dt. So this is going to be equal to 60 times 14 minus 11, which is 60 times 3, which is 180 miles. And that's it.